Okay, so let's discuss about non-relational databases. So in non-relational database, unlike the relational databases, there are many different types, because in relational database, mostly we will have the databases where we will store the data in rows and columns. But there will be differences in the different isolation levels or the principles. But coming to the non-relational databases, we will be having different types. Where the data storage types is also different, and among them here we will discuss mostly these three types. The first one is document DB, next key value stores, and the graph DB. Okay, so let's start one by one. First, let's start with the document DB. So in the document DB here, we'll take the example of MongoDB. That's a very famous document or non-relational database that is used across the industry. Okay, so here, first of all, let's understand what are the limitations of the relational database that we are solving, or that is overcome using the non-relational database, that is, for example, MongoDB. So the first thing here is the scalability. Okay, so now here, coming to the part of scalability or any of these limitations, it is primarily dependent on the kind of data we are storing. Okay, so for some kind of data, this MongoDB or non-relational may not be scalable. Okay, so only some certain kind of data that we are going to store. So if those kind of data, if stored in the non-relational database, then it will help us with the scalability. Okay, so let's take an example of the chats. Okay, so for example, here at the present date, we are using many AI applications like ChatGPT, Gemini, or Anthropic Cloud, right? So there, when we chat or when we log in every time, we will be redirected to a new chat, and at the same time we will be able to see our older chats also, previous conversations. So now, taking that example, if you think like, if you are given to store those kind of chats, which database will be the right option? So let's understand that. For example, if we go with the SQL database, then we need to maintain at least 3 databases. Here we are just going like an overview. We are not going in deep, but at least here we need to maintain 3 databases, 3 tables. That is, first we'll be having the user details in the user table. Then we will have the chat details, like every different chats we will do whenever we log in. And then for every chat, there will be conversations. There are different messages of the user and the AI, right? So there are, these are the 3 tables we must have to store the whole data, right? So now that's on the SQL side. But now if we store the same data on the document database like MongoDB, then within one document, we can store all these data for per user, right? For example, for a user with a user ID 1 and the conversation, let's say we give ID for the conversation as 1, then inside that first conversation, we can have all the messages, all the conversations. Then under the same user ID, we can have the next conversation ID 2, and then all the conversations. So all the data related to the conversations done with that AI agent for that user will be under one document. Okay, so now how this is going to help us in the scalability? So now when do we think about scalability? When the size of the data gets bigger, right? So now let's say the size of the data or the users grows, then when we need to divide the data here with the SQL, what we need to do, we need to divide all the 3 tables. Okay, so now in this case, the users table may have very less number of rows compared to chats and messages. Messages may have many number of rows. So now when the data gets divided or sharded, it will get inconsistent. Some like a small amount of data will be left in the one shard, and another shard will have another large set of data, right? So the next time when we try to read it from the application, the reads will get difficult. But now when compared to MongoDB or the document database, if we needed to shard, then we can shard the data very easily here. We can just shard on the basis of the shard ID. Let's, for example, user ID. So let's say for user ID 1 to 100, we can just keep them on the database 1, and then from 100 to the next 200, we can just keep them in the next database or in the next node or the next shard. and that the routing will be automatically taken care by the MongoDB on the basis of the user ID. So on the application side, we do not need to make any bigger change. But here, if we share the data on the SQL kind of database, then we also need to make the similar changes in the application side. So here, the scalability for such kind of data is very easier and efficient when we go with the non-SQL database or the database like MongoDB. Next, coming to the data structure flexibility. Okay, so taking the same example, now let's say for every message we also want to store the user response, right? If you have seen on ChatGPT or any other application, we will get an option to select like the response or unlike the response. So let's say here I have added one more parameter, that is the user response as a Boolean value. Okay, let's say true or false. So now in this case here I need to add an extra column, and that column gets added to every messages. So maybe that feature was introduced later point of time. In that case, that column will get added to all the previous messages also, right? So now the reads will become, when the application will read it, the serialization and deserialization will become difficult, right? But now here in the case of MongoDB, where we store the data in the form of JSON, there we just need to add one more parameter in that JSON object, right? And that can be there for some data, or that cannot be there for some other chats. Okay, so that will not affect the serialization and deserialization. So this flexibility is there with the non-relational database, or when we store the data in the form of documents. Okay, so now that's about the data structure flexibility. Next, coming to the high writes and high read throughput. So here again, when we store the data in the SQL databases, and when we try to read, there will be many complex joins for every reads, right? In that case, the database needs to scan multiple tables to get back the response. But when compared to the same data, when we are reading on the MongoDB, we just need to get that one document related to that one user and that one chat, and then we can get all the messages from that document, right? And for example, here if we say that let's say there is 1 second of period, like if we are calculating the number of reads that can be done in 1 second, and we compare that to MySQL and MongoDB, we'll definitely have higher reads, higher throughput for the MongoDB, because the number of the ease with the MongoDB will respond will be much higher than the SQL, because in the SQL we need to scan the whole table, or we need to like transition from one table to another table when we have multiple joins, but that is not the case with the MongoDB. So that is the reason the throughput of the MongoDB or the document database will be higher when compared to the SQL database. So these are some of the things or the advantages that the non-SQL or the document databases give when we have such kind of data to be stored. But if we have a data like transactions, or for example, in e-commerce application, we want to store the orders, right, where we need the higher ACID principles, like the consistency or the isolation is needed, then for such kind of data, we definitely need to go with the SQL databases. But for the data like the chats or the logs, or the product catalogs, right? For example, on the Amazon, if we go to any of the product, let's say if I log into Amazon, and if we search for any product, okay, let's say if I go to refrigerator, so here the data that I'm seeing for the refrigerator will be different from the data which I may see for some other things. Let's say if I go to any other data, so here the data which I will see will be different, right? And the data which I will see for this product will be different. So basically the product catalog will be different for different data, for different products. So such kind of data, if I want to store, then definitely we need to go with the document database or the NoSQL database. So I hope you were able to understand here what is the difference between document DB or a NoSQL database and the SQL database, and in which condition we should go with non-SQL databases. Okay, so next let's discuss about the key value store. Here we will discuss about we'll take the example of Redis database. Okay, so next let's look at the next NoSQL database, that is Redis. So here Redis is a key value store kind of database where the data is stored in the form of key and value. Like for example, here the data will be stored like key value, where for example the key can be the user ID, let's say, and the value can be the user credits. For example, if we take the example of OpenAI or ChatGPT, so here we buy the credits to use the API, right? So let's say I bought a credit of $5. Now this data can be stored in the form of key value in the Redis database. So now in this context, let's say here the users have bought the credit, and this data will be definitely stored on the MySQL database where it will be permanently stored. And now when the user make a API call to the OpenAI backend, now for all those API calls, the backend has to make a call to the SQL database to check that whether the user has appropriate credits. So if he has or she has, then he will get the response, else he will get the error response. So now for there will be millions of users making the API calls, and if we make so many API calls to the SQL database, then that will be an operational overhead that will reduce the performance. So for making a faster response and for the higher performance, we can use this Redis database as a cache, where we can store the same data in the cache and then we can do the same operation. And here now, how does it make the difference? Like instead of using MySQL, if we use Redis, then how does it make the difference? So the difference here it will make due to these properties. So the first property is the due to the protocol. So here the way the client and server communicates over HTTP, the Redis uses its own protocol, that is a Redis serialization protocol. And how this is different here, because this protocol does not need any headers or methods or status code, and it also does not need to do any content negotiation as the server does, right? So here the content is always a fixed line based text format. Now due to this, the response and the reads and the writes with the Redis database is much faster compared to the traditional SQL database. Next, what is the other advantage here we have is the single threaded. So Redis database is single threaded, where due to that there is no concept of locks or the race condition that results in the lower latency and more consistent performance. Next, we have is the deletion policy. So the deletion policy is in two ways. So the first way is which is automated, where the Redis automatically does a policy deletion check or the database, that is every 100 microsecond, that is 10 times per second, where it will randomly collects sample data set of let's say 20 data sets, and in that it will check how many are expired. Okay, how many data is expired, because every data stored on the Redis is set with a TTL, that is time to live. Okay, so if any set of data has expired the time, then those will get deleted in this cycle, and that will happen until the data set has more than or equal to 25% of data is already expired. Okay, so if not, then that operation will not be executed. So that is the first way of deletion policy. And the second way is, let's say when the user or the backend calls or gets some data, and if it is already expired, then it will automatically get deleted and the backend will not get any response, and in that case it needs to get the data from the main database. Okay, so that's the deletion policy, and due to that the data maintained in the cache is always consistent, and due to that the reads and the writes are much faster. And the last and the most important factor is because of the in-memory storage. So what do we mean here? The data stored in the SQL or relational database is on the memory, on the disk. Okay, so data is stored on the disk, but here the data is stored in the memory, that is in the RAM. Okay, so as the data is stored on the RAM, the reads and the writes are way faster when compared to the reads and writes on the memory. Okay, so these are the four critical reasons why the Redis database is faster here, and why NoSQL database is used for the caching. Okay, so that's about the Second kind of NoSQL database, that is key value store, and similarly we have DynamoDB that is provided by AWS, and here Redis is open source, so that's the difference, but both of them helps in the key value store. Next, let's discuss about the graph database. That is the another kind of NoSQL database. Okay, so let's discuss the next NoSQL database, that is Neo4j. So here Neo4j is a graph database, and why we call it as a graph database, because the data here stored is in the form of nodes and pointers. Okay, so here a node is where a data or the object gets stored, and the pointer is a connection between those nodes. Okay, so that pointer is created by the system according to the requirement. For example, here the node or the data is the user. Okay, let's say the name, the Raghu, and another node is the movie. Okay, now the pointer between them is of type watched. Okay, so the here what does it finally becomes? The user Raghu has watched the movie Inception. Okay, similarly the user John has watched a movie Interstellar. Okay, so like this the data will be basically stored in the graph database. Okay, now where these kind of databases are used? So these are mostly used in the recommendation systems, in the fraud detection. Okay, so in such scenarios these databases are used. So let's take one example of a recommendation system. So now let's see how the database like this helps in the recommendation system. So here let's take an example where right now the data is stored in this way, where the user Raghu has watched the movie Inception, and he has also watched the movie Interstellar. There is another user John who has watched movie Inception, and he has also watched movie TNet. Okay, so this is how the data is basically stored in the graph database, where this is the node and this is the another node, and in between we have the pointer of type watched. So this pointer can be different according to the requirement. Okay, next, now comes the query. So if in the case of SQL, we have a SQL query, that is structured query language, but here in case of Neo4j, the graph database, we have the Cypher query. Okay, so now what does this query is doing here? So in this query, what we are saying, so give me all those users who has also watched the same movie which the Raghu has watched. So here Raghu has watched Inception and Interstellar. So now another user which we have is a John. He has also watched one of the movie which Raghu has watched, that is the Inception. Okay, so now this is the user that will get returned. Okay, and then we are adding a filter, that is where return me all those movie titles which the other user has watched but the Raghu has not yet watched. So that will be the TNet, right? So now this TNet movie will get recommended to Raghu. Okay, and at first place both these people will be friends or they will be connected somewhere, and then this second connection forms. So this is how all the social media works, where we'll have a connection with one of the other person on the social media, and then they will form a connection like this, where we both might have watched a common movie, and then for both of us they will recommend something which we have not yet done together. Okay, for example, to John the movie Interstellar will get recommended, and to Raghu the TNet movie will get recommended. Okay, so because this connection is getting formed, right? So this is how the Instagram also works, where you may have observed, like if you start liking a kind of reels, or if you start sharing a kind of reels, then if you, after a couple of moments you will see the same kind of reels get recommended to you, because similar users might have shared or liked the kind of reels, right? So this is where the graph database helps. Like this is the way the data will get stored, and because of the high network, it's very easy to reach that data within that network. But in case if you imagine this data is stored in the form of tables, then we needed to traverse multiple tables to get to that data. So here we are not saying that this cannot be done with a SQL database. It can be done, but the efficiency will be very low, right? Because there are millions or billions of users doing multiple activities at the same time. And now to make everything connected, we should have this kind of database where the nodes will get connected, and it will help us easily to get to some recommendations. Okay, so I hope you're able to get this kind of NoSQL database where we are storing the data in the form of nodes and pointers. Okay.